All right. We have looked at problems where when you take the limit, you get an answer of infinity. We've looked at problems where you take the limit and you get an answer of negative infinity. What we haven't really looked at is what happens when you take the limit at infinity. Can you get a number? Can you get infinity? What are the possibilities here? So we're changing the problem a little bit to take into account some different limit type problems. And a lot of it comes down to horizontal asymptotes. If you can find horizontal asymptotes, you'll be good to go. I've talked a little bit about horizontal asymptotes already. We'll review them again today just to make sure you have this under control. Okay? Infinite limits from the left and from the right. What happens when you approach positive infinity? What happens when you approach negative infinity? Use some vertical asymptote graphs to answer some of the problems we've already talked about here. What happens when you take the limit as you approach 5, when 5 is an asymptote? How do you deal with that? We'll talk about some problems where you look at it and you start doing all kinds of algebra, but you forget that silly thing of just plugging and chugging. And then we'll talk about limits of infinity at infinity, and we'll do a review of horizontal asymptotes. A lot going on. Okay. So, horizontal asymptotes. Let's start with this function. 3x squared over the quantity x squared plus 1. We have a horizontal asymptote at 3. So what happens, well, I'll ask you this. What does a horizontal asymptote do? What is it? Who's talking? Ooh. Interesting. Let's go back to a vertical asymptote. Can a function ever cross a vertical asymptote? Why? Sorry.
Because it gets really, really close to 0 and then it crosses.
And what would happen? I'm trying to think how to phrase the question. Why can't the function
Undefined at that point.
Good, because the denominator would be 0. Okay. So Maria, you said that it can never be that y value.
Yeah. No.
Now you're doubting yourself.
Yeah.
Because I got all excited about
Pretty
it.
significantly. Yeah.
Can a function cross a horizontal asymptote?
Yes.
Does it commonly cross a horizontal asymptote? No. So what you've seen from pre-calc is that it will occasionally do something weird like bounce above the horizontal asymptote and then level out again. But we want to talk about what happens when you go really far away. What happens when I carry this graph all the way out to infinity in that direction? Could it cross the horizontal asymptote? Yes. More than likely, if it does cross a horizontal asymptote, it's going to happen close to 0 or in a reasonable amount of space, from -5 to 5, etc. When you get very far out, that graph gets closer and closer to 3. Does it ever hit 3? It might. I mean, I could set f of x equal to 3 and solve it and see if I can come up with a value. I'm probably not going to hit it. So we use the term it's asymptotic to 3, meaning it gets closer and closer and closer, but never really hits 3. That's the concept that we're going to use to solve a lot of these problems. In this picture, if you look at it, when I go very far out to the right, the function approaches 3. When I go very far to the left, the function also approaches 3. Okay? And that's something new. We've looked at limits getting answers of infinity and negative infinity, but not limits where you're approaching infinity and negative infinity. That's the twist for today. And they're actually, I think these are a lot easier than the other ones, personally, but I'm weird about it. Okay, so there's the notation. That's the difference now, is we're taking the limit as x gets very big and getting a numerical value. What we've done before is the limit as x approaches a numerical value and get infinity or negative infinity. So, review of the 3 scenarios. If you have this under control, great, don't write it down. If you don't and you're still sketchy about it, it's an important concept. If the degree of the numerator is less than the degree of the denominator, your asymptote, your horizontal asymptote, is the x-axis, also known as y equals 0. That's probably the most common. think Starbucks needs to get better ice. Because when it melts, then the ice cubes get small enough that they get sucked through the little thing and I end up choking on ice. I'm just saying. Or they need to build like an ice filter into the cup. The struggle is real, kids. Case number 2, when the degrees are equal, it's the leading coefficient fraction, A over B. And then the third one that nobody likes are the oblique asymptotes. And yes, we will deal with those, but I'll show you some tricks to make your life a lot easier. Theoretically, you're never really going to have to divide it out, because I have some ideas that will help you figure out what's going on with the function, but that comes later. We'll save that one for last. Okay? So let's go back to the first one. That guy. Degree of the numerator is 2. The degree of the denominator? 2. Therefore, we're in case 2, which makes the horizontal asymptote at 3, which you already know because I told you that. As the limit gets very big, the value of the function the limit of the function, I should say, at that infinity or negative infinity will be the value of the horizontal asymptote. If you can find the horizontal asymptote, then theoretically you can find the limit. Find the horizontal asymptote, you get the limit. Okay, make sense? Yeah, great. Solve that. Oh wait, 3 different techniques. Well, what's one technique? Andrew, take that out of your ear. Nadia, what do you got for me?
Well, you could plug and chug, but since it's infinity, you can't really do that.
You can, but it requires a little bit more work, which you probably don't know, and I'll get to that later. What else could you do? That's one of the 3 techniques, which I'll come back to. What are the other 2?
Graphing.
Beautiful. Good. Any guesses on the 3rd technique?
Find the horizontal asymptote.
Bingo. Where's the horizontal asymptote there?
3 over 4.
Excellent. So I should get an answer of 3 over 4, right? Okay, good. I went out of order with my slides, so I'm going to do the weird one first, which is what you said originally, plug and chug. Okay, what happens when I plug and chug? I get a train wreck. What is infinity squared? Infinity. What is 3 times infinity? Infinity. It doesn't get us anywhere. So the first trick involves dividing by the highest exponent. So those are degree 2 equations. So if I divide everything in the problem by x squared, I get an absolute mess, but it simplifies into that pretty little picture over there on the right. Now we plug and chug. Nadia, what happens, let's take 3 over x for instance. What happens in 3 over x when x gets very big? What happens to the value of 3 over x?
It gets smaller.
Ooh, how small?
Very small.
How very small?
Like negative.
No, not that small.
0.
Bingo. Okay. That's an important concept. As the denominator gets very, very close to 0, that fraction becomes 0. So all of a sudden, that goes to 0, that goes to 0, this goes to 0, and what are we left with? 3/4, which we already knew was true because that's what Nadia said. She's very bright. That's technique number 1. Not the most common, but I still feel like you need to see it because it can be used if it makes sense to you. But the key here is dividing by the highest degree. That way things cancel out and you're left with just those fractions. Okay, so 3/4, which is what we knew already going into it. Technique number 2, horizontal asymptote. We talked about that already. Bingo. Technique number 3, graph that puppy. And you can see the horizontal asymptote. Oh, look, a function where it crosses the horizontal asymptote. You'd think I would have planned that. I didn't, I just got lucky. Can cross a horizontal asymptote, never cross a vertical asymptote. Now, which of those three techniques are you going to use? I'm guessing most of the time you're going to use the horizontal asymptote approach because you might not always have a calculator, you might not always have Desmos, and nobody in their right mind is going to want to do that mess. But you can if you're feeling saucy. Okay. Try that one. Okay. Not the only way to do the problem, but I use the limit laws. The limit of a difference is the difference of the limits. Broke it into two different limits. The limit of 5 as you approach infinity is going to be 5. We talked about that. If there's nothing to plug in and just the numerical value. And then 0 comes from what we talked about in the last screen. As the denominator gets very, very big, the fraction gets very, very small down to 0, and we're left with 5. Okay. Probably the choice that I would make to solve that problem would be using that method. However, we could also do some pre-calculus and get a common denominator. Now it becomes a problem like we talked about with Nadia, where you have 3 different options. You could use you could use the horizontal asymptote. You could divide everything by x squared, or you could graph that puppy. Any one of the above will get you that answer that we're expecting of 5. And we know the answer to the question because we've already talked about that. Degree of the denominator is 2, the degree of the numerator is 2, therefore the leading coefficients give us a horizontal asymptote of 5, which is our answer. I forget what I put on my slideshow. So did I give you the answer to this one? I did not. You gotta do this one on your own. You done yet? Good. What is it? It's 2. There's a picture if you don't believe us. But, again, horizontal asymptote. Done. Okay. Don't make it more difficult than it has to be, and this is why we go back to my original statement. I think this stuff is easier than some of the other stuff we've been doing. Vertical asymptote. We've dealt with these a lot, and I want to talk about refreshing your memory on how to find a vertical asymptote. Where's the vertical asymptote in that problem? -1. Beautiful. Now, 3 questions come about from a function like this. Question number 1, what is the limit as x approaches -1 of f of x? The answer? Say again? DNE. It's an asymptote. Okay. That's question number 1. Question number 2. What's the limit as x approaches -1 from the positive side of f of x? So think about this graphically. I have a rational function with a vertical asymptote at -1. It's going to do one of 4 things. Here's my asymptote. It's either going to go up on this side, down on this side. Or it's going to go down on this side, up on this side. Or, what are the other 2 cases? Both up or both down. Have you heard the term multiplicity before? Yes or no?
Yes.
What does it mean? Okay, you've heard it, you don't know what it means. Okay, multiplicity has to do with the power or the exponent on the terms that generate your vertical asymptote. Okay, that has a multiplicity of 1. because the exponent there is 1. Why do we care? If the multiplicity is odd, then you're going to have one side go up and the other side go down. It's going to be split. It's either going to do this or it's going to do this. If the multiplicity is even, then they're both going to go up or they're both going to go down. Okay, so let's get back to the question now. I know the multiplicity is 1, so I know one side of the asymptote is going to go up and the other side is going to go down, but I don't know which is which. How do you figure that out? How do I know what's happening on the right side of the line of the vertical asymptote, x equals -1?
Plug something in on the,
Great, what would you like to plug in?
you said on the right side of -1?
Yes, sir?
4.
4 would be good. And?
Just on the right side?
Yeah.
3, 4, 5, 6, 7, 8, 9. 374.
All of those work,
0.
but how does it answer the question? So what is the limit then on the right-hand side of the asymptote? Does it go up or down?
I'm not sure.
Anybody else? Oh, by the way, this is calculus. Is 4 a really good number in calculus to plug in there?
Probably not.
No? It's not horrible, it'll get us where we need to go. What would be a better number? Say again? No, we're on the other side. Yeah, -0.999. Okay. So let's plug in a number a little bit bigger than -1, like -0.999. Is the denominator going to be positive or negative? Bryce? You sure?
Yeah.
Good, just checking, see if I can get you to change your answer. Positive. The numerator is positive always, so therefore, this is infinity. Okay. What you would have done last year in pre-calc is the same idea. You would just look at whether the answer is positive or negative, and we're doing the exact same thing. The third question would then be, you see where this is going, what's the limit as x approaches -1 from the negative side? I put in a number a little bit more negative than -1, -1.1. When I put -1.1 in here, the denominator becomes negative, the numerator is still positive, we go to -infinity. That process becomes fairly repetitive, but is also very common with vertical asymptotes. No limit at the asymptote, then you have to figure out what's going on the right and left-hand side. Okay, and again, multiplicity will come into account there. I didn't really need to think too much about this because once I recognize the multiplicity of 1, I know that if this is infinity, the other one's negative infinity. If this was negative infinity, the other one would be positive infinity. Okay. Where are the vertical, notice I said are, not is, where are the vertical asymptotes for this guy? 1 and -1, correct. Because that denominator factors, the numerator does not factor. Then you go through the whole process again for each of those points to figure out where you get that, and then I'm pretty sure the last one I've got a multiplicity on it. By the way, these both have, when you factor the denominators in part B, both of those asymptotes are going to be a multiplicity of 1, because it's x minus 1 and x plus 1. And then the last one, oh, it's a cotangent. Cotangent. Trig. Hot diggity. Where are the asymptotes on cotangent? 0, pi, 2 pi, 3 pi, negative pi. Yeah, they're factors of pi. Okay, so there we go. We talked about the asymptote. Pretty much I covered this already. Going very high on the left, going very high on the right. They both go up, they both go down. We're good to go. Okay. The last one, yeah, that's all. We don't care about that. Do that without a graph. Now we talk about multiplicity. And so that's no different than the one we just did, except now all of a sudden we have a multiplicity of 2. So that means once I find one side of the asymptote, I automatically know the other side of the asymptote is going to match. Odd multiplicity, different answers, different signs. What I want to get to is this guy. Okay. So graph that, either on Desmos or on your calculator, and I'd like you to answer those 3 questions. By the way, how many asymptotes are there?
2.
There are 2, good.
I left it on here, but I don't like it.
I understand. Yeah, I like Desmos better too. Especially since you can like easily pinch it and stretch it and do all the other fun stuff. Yeah.
Be careful, if you're using your calculator, you gotta use some parentheses there, otherwise you get a funky graph that doesn't apply to anything we're talking about. Okay, let's get the 2 easy ones out of the way. Eunice, where are the asymptotes?
I got -3 and 0.
Could you specify which is which here? -3 is what? Is it vertical?
Oh, no, horizontal.
-3 is horizontal.
Oh, no, positive.
+3 is horizontal, not vertical. You sure?
I got 0 for vertical.
Vertical asymptote at 0, horizontal asymptote at 3. You're at 50%. I agree with the horizontal asymptote, okay, because leading coefficients. Well, what makes that denominator equal to 0?
Oh, negative.
-3. Okay, so we got an asymptote, a vertical asymptote at -3. We've got a horizontal asymptote at 3. The multiplicity of the vertical asymptote is odd, so therefore one side's going to go up and one side's going to go down. And if I remember the graph correctly, it goes down on the right and up on the left. Yep. What about number 2? What kind of limit questions would you ask about this picture? let's call this g of x. So I have to write the function out. Ideas? Maria, what do you got?
And put x to infinity.
Okay, I like that. That's good. Do you have an answer for me?
3.
You bet. Okay, that's 1. Limit as x approaches what? Don't say negative infinity because it's not very exciting. We already got that taken care of. What else would you ask?
No.
Say again?
X approaches
Approaches negative 3. You want a direction on that? You just go straight up negative 3.
well, you could do directions.
You're driving the bus. What do you want to do?
I like easy ones, so just that.
Okay, what's the answer?
Just easy.
Good. So then we pretty much take care of the other two, right? We could do 3 from the positive, 3 from the negative. In fact, let's do the positive side, only so that we can see what's the limit as x approaches negative 3 from the positive side of g of x. Okay, you have a picture in front of you. What's the answer to this guy? Does it go down or up?
Down.
Down, which means the answer is negative infinity. Because the multiplicity is 1, I know right away negative 3 from the negative side is going to be positive infinity. And then the other weird one that you could ask is you could just throw a number in there. What is the limit as x approaches 7 of g of x? How do you do the math? 5, 15, 15 over 10, so 3 halves. Right, plug and chug. Okay. Nothing exciting happened at 7, it's just a plug and chug. Okay. Bingo. Now, what happens in this case? You all know what the graph of x cubed looks like. When you go very far to the right or very far to the left on x cubed, the function keeps going up and up and up to the right. When you go to the left, it keeps going down and down and down. So it is possible now to take the limit as x approaches infinity and get infinity as an answer. The same is true with a function like even x squared. You continue going to the right, it continues going up. You continue going to the left, it continues going up. This idea is what I want to use to talk about oblique asymptotes. Okay, so let's suppose we have something like x cubed plus 2x minus 4 over x squared plus 1. I know that there's going to be an oblique asymptote there. I don't care what the oblique asymptote is. There's only one thing I'm concerned about, and that is, does the oblique asymptote go like this, or does the oblique asymptote go like that? In other words, does the oblique asymptote have a positive slope, or does it have a negative slope? How do you figure that out? There's a real simple trick. I look at the leading coefficients. If I were to go and find the oblique asymptote, by the way, did you find oblique asymptotes at pre-calc? Did you have to go through that hell?
No.
No? Beautiful. Good. If you had to find it, you would have to do long division. X cubed plus 2x minus 4 divided by x squared plus 1. Okay, or synthetic if you want to use synthetic, it doesn't matter. And you'll get a line. The trick that I use is I just look at the leading coefficients. I'm going to divide a positive value by a positive value. That's going to give me a line that has a slope of a positive value, which means I'm now dealing with the red line. Once I know that, then I can easily answer the question of what is the limit as x approaches infinity of this puppy? Since the slope is positive, it goes off into infinity. Okay, because the slope continues to get bigger as you move to the right. Don't sweat the oblique asymptotes as much if you could just look at the leading coefficient and determine if the slope is positive or negative. Then you can figure out what the limit is as you approach infinity or negative.